Hi, welcome to today's lesson. Today we're going to be talking about counting principles, permutations, combinations, and factorials. We're going to do some very easy examples just to remind you what these are. These are the building blocks. You have to be able to know these before you can do harder problems. I hope you enjoyed today's lessons. We can begin our discussion of permutations and combinations with the multiplication principle. This principle has three rules. Let's talk about rule 1 right here. Rule 1 says, if any one of n mutually exclusive and exhaustive events can occur in each of k trials, the number of possible outcomes is equal to n to the k. N is the number of possible outcomes, k is the number of trials. For example, if you're rolling a number cube, that's a die, twice, how many possible outcomes are there? There's 1, 2, 3, 4, 5, or 6. So there's 6 possible outcomes. How many trials are you doing? Well, we're going to do it twice, so it's 6 squared. Another example would be picking 3 cards with replacement from a standard deck of cards. Well, how many possible outcomes are there? There's 52 different cards. And how many trials are we doing? 3 trials. So the possibilities would be 52 to the 3rd power. The second rule of the multiplication principle states that if there are n1 events in the first trial, n2 events in the second trial, and so on till you have nk events in the nth trial, then the number of possible outcomes is equal to n1 times n2 times n3 times n4 times n5, etc., 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 all the way down to n to the k. Well, what does that mean? Well, we see it's a multiplication principle and we're multiplying. That should be no surprise. How does this work? Well, for example, how many different outfits are possible if you have 5 different hats, 4 different shirts, 3 different pants, and 7 different pairs of shoes? Well, in our first trial, we have 5. In our second trial, we have 4. In our third trial, we have 3. And in our last section, or our trial, we have 7. And that is equal to 420 different outfits you can wear with these parameters. Our third rule of the multiplication principle is this. The total number of ways that n different objects can be arranged in order is equal to n factorial. What is n factorial? It's n times n minus 1 times n minus 2 times n minus 3, etc., 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 all the way down to 3 times 2 times 1. Note, this is very important that we define both 0 factorial as 1 as well as 1 factorial is equal to 1. Well, how does this work? In how many ways can you arrange 10 objects? In how many ways can 10 objects be arranged? Well, that's equal to 10 factorial, which is 10 times 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1, which is equal to 3628800. So that's over 3.6 million ways. Well, we've already talked about what factorial means. The next step is to talk about permutations. Permutations are the total number of ways to arrange n objects taken r at a time. The symbology is npr is equal to n permutation. That's the total number you want to arrange taken r at a time. So we have to divide by n minus r factorial. First you have to find out what n minus r is, and then you take the factorial. Order matters. With the permutation, order matters. It's also called an arrangement. When you hear arrangement, you can think permutation. And the key spot here to remember is that order does matter with the permutation. Here's an example using permutations. If there are 40 sailboats racing for gold, silver, and bronze medals, how many possibilities are there for the medal winners? Well, the first question you have to ask yourself, does order matter? Of course it does. If we're going to give away gold, silver, and bronze medals, that's for first, second, and third place. So a sailboat from Ethiopia, then Kenya, and Brazil is different from Brazil, United States, Kenya, etc. So order does matter. If order matters, we're talking about permutations. Well, we know it's NPR. Well, that's the total number of possibilities. We have 40 sailboats. Permutation taking how many at a time? 3. So out of the 40, how could we arrange 3? Arrangement is another word for permutation. We know that's going to be equal to 40 factorial over 40 minus 3 factorial, according to our formula. which will give us 40 factorial over 37 factorial. And so our final answer is going to be, if I do it on my calculator, 59280. 59,280 different ways we could finish first, second, and third with 40 going for 3 spots. One thing we have to be careful of is, when dealing with permutations, is something called permutations with repetitions. The number of permutations of n objects, of which n1 are identical, n2 are identical, n3 are identical, etc., all the way out to nk are identical, I don't know how many identicals I have, is given by n factorial, which we saw before, divided by, well, when we divide we make the number smaller, so it's going to be less than what we had originally, divided by the number of repetitions factorial, number of repetitions factorial, all the way out to, I don't know how many repetitions we're going to have factorial. This could be confusing. Let's see what this looks like in an example next. Here's an example of a permutation with repetition. For example, how many different arrangements of the word hippopotamus are there? Well, if it was a word with no repeats, then we wouldn't have to worry. It would simply be the number of letters factorial. But here we have 2 P's are the same, and 2 O's are the same, and actually I've got a third P in here. So I've got 1, 2, 3 P's and 1, 2 O's. So what does that mean? If I switch this P and this P, if I make a different arrangement and I switch those P's, we're still going to have the word hippopotamus. Alternatively, I could switch the 2 O's and we're still going to have hippopotamus, even though I have changed the letters. So the number of arrangements, when we see the word arrangement, we're thinking permutation. The number of arrangement is going to be, as we saw in the formula, the total number of letters, factorial. Well, we've got 12 letters, so 12 letters in hippopotamus, factorial. That's the total possibilities for the ways to arrange the 12 letters of hippopotamus. But our number of arrangements is going to be less, because if we switch the O's, we still have the same word. If we switch any of the 3 P's, we have the same word. We divided by, well, we've got 3 P's, so divide by 3 factorial. And we've got 2 O's, so we divide by 2 factorial. And that will give us a total number of arrangements of 3991680. So this is 39 million different ways, which is smaller than if we did just 12 factorial, which would be if we had no repeats in the letters. So we talked about permutations. Permutations are also known as arrangements, and order matters. Another way to order data is combinations, also known as selections. What is a combination? A combination is a process where order has no importance. In other words, order doesn't matter. For example, the total number of ways of selecting n objects taken r at a time, the total we want to select from is n, we want to only select r of them, is given by n factorial divided by n minus r factorial, which is the same as a permutation. Also, multiplied in the denominator is r factorial. So if we have, one way to write it would be NCR is n factorial divided by n minus r factorial times r factorial in the denominator. Another way you see this is NR, like that. It's written like that, and they both mean the same thing. Notice, it's going to be smaller than the order matters permutation, because we're dividing by an additional factor of r factorial. Here is a very straightforward example using combinations. How many ways can 3 class representatives be chosen from a class of 20 students? Well, it's going to be, because our order doesn't matter. It doesn't matter if we go Bobby, Susie, Billy, or Billy, Bobby, Susie. We just need the 3 names out of the 20. So because we're selecting 3 students, order does not matter. It's going to be NCR will equal, well, 20 students. We're going to select out of that 3. Which, of course, according to our formula, is 20 factorial divided by 20 minus 3 factorial, which we simplified as 17 factorial, times, in the denominator, 3 factorial. Ultimately, this gives us 1,140 different ways.